And now in this lecture we'll answer on two questions. In the first question we'll find out the below area, and in the second question we'll find out the radius of the circle that blocks triangle ABC. So we'll start with the first question. In the drawing we have a circle. Inside this circle we have triangle ABC, and inside triangle ABC we have small circle that is actually inscribed by triangle ABC, and we want to find out the blue area. Okay, so first of all we will define. We know that actually that the radius of the small circle is equal to 4 units, and the radius of the big circle is equal to 13 units, and we want to find out the blue area. So first of all we define the center of the small circle as point O. We define the point of tendency with the point of tendency of the small circle with tangent BC as L. We define the point of tendency of tangent AC with this small circle as M, and we define the point of tendency of tangent AB with the small circle as S. We will join points O and S together by a straight line. Here we have rule number 1 that says that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here OS is the radius of this circle that is equal to 4 units. So here the radius OS, it is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AB with this small circle, and whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. So AB is perpendicular to SO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join here points O and L together by a straight line. O is the center of the small circle. L is the point on the small circle itself. This is exactly the definition of a radius. That is to say, here ON, I segment ON equals to R, the radius of the circle, that is equal to 4 units according to what is given us in the question. So here the radius ON, it is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent BC with this circle, and whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius OL. So if CB is perpendicular to LO, it means that this angle equals to 90 degrees, and this angle will also equal to 90 degrees. Likewise, we join points O and M together by a straight line. Here O is the center of the small circle. M is the point of the small circle itself. This is exactly the definition of a radius. That is to say, OM is the radius of the small circle that is equal to R according to our definition, and R equals to 4 units according to what is given as the question. But here the radius OM, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AC with this circle. Whenever you have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius MO. So AC is perpendicular to MO. That is to say, this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. Okay, and I didn't mention that AB is the diameter of the big circle. Okay, AB is the diameter of the big circle, and we have the rule that any peripheral angle that rests on the diameter equals to 90 degrees. So here, angle ACB, this angle ACB, rests on AB, that is the diameter of the circle. That is to say, it is equal to 90 degrees. Okay, according to the rule that any peripheral angle that rests on the diameter of a circle is equal to 90 degrees. The peripheral angle ACB, angle ACB rests on the diameter of the circle, that is AB, therefore it is equal to 90 degrees. So actually, if we focus on quadrilateral MCLO, in quadrilateral MCLO, we have 1, 2, 3 right angles. Again, in quadrilateral MCLO, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of angle LOM, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we'll get that the missing angle LOM, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. Angle LOM equals to 90 degrees. So I found out that this angle LOM equals to 90 degrees. It is a right angle. So actually, quadrilateral MCLO has 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we will relate to quadrilateral MCLO as a rectangle. Why? Because it has 4 right angles. So quadrilateral MCLO is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle MCLO, we get that OL equals to MC. OL equals to MC according to the rule that the opposite sides of a rectangle are equal to each other. OL must be equal to MC. Okay, but OL equals to 4 units. It is the radius of the circle. So we can write here that OL equals to 4. And from this equation, we get that 4 equals to OL equals to MC, we derive that MC is also equals to 4 units. MC equals to 4 units. So we can write here that MC equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we'll get that side MO of rectangle MCOL, side MO must be equal to side CL. I repeat again, MO must be equal to CL. But here MO equals to 4 units, this is the radius of the circle. So MO equals to 4, and from this equation 4 equals to MO equals to CL, we will derive that CL is also equals to 4 units. CL equals to 4 units. So we can write here that CL equals to 4 units. Okay? In the next step, we will define side AC of triangle ABC as A. So AC equals to A according to our definition. Okay, AC equals to A according to our definition. We define side CB as B. CB equals to B units according to our definition. CB equals to B units, and we define side AB as C. AB equals to C units according to our definition. What is the value of AM? AM, it is very easy to see from the drawing that AM it is equal to AC minus MC. AM equals to AC minus MC. That is to say AM equals to AC. AC equals to A according to our definition. And MC equals to 4 units according to what we have already found out. So in conclusion, we found out that AM equals to A minus 4. Here AM equals to A minus 4 units. Likewise, what is the length of line segment LB? The length of line segment LB, from the drawing it is very easy to see that LB equals to CB minus CL. Okay, line segment LB equals to CB minus CL. So LB equals to CB equals to B according to our definition. So let's substitute CB by B minus CL. Here CL equals to 4 units according to what we have already found out. So in conclusion, we found out that LB equals to B minus 4. LB equals to B minus 4 units. In the next step, I present to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So we focus on the common external point, point A. Point A is the common external point in relation to the small circle, because it is not located inside the small circle, nor on the small circle, but is located outside of the circle, therefore it is common external point. So from the point A, we have two tangents to the small circle. Two tangents to the small circle. Tangent AM, this is the first tangent. tangent AM is tangent to this circle at point M. Point M is the point of tendency. And we have also tangent AS. And according to rule number 2, it says that the length of two tangents from a common external point to a circle are equal. AM must be equal to AS. Here, from point A, we have two tangents to this circle, tangent AM and tangent AS, and according to rule number 2, they must be equal to each other. So AM equals to AS according to rule number 2. But we have already found out that AM equals to A minus 4. So you can write here that AM equals to A minus 4. And from this equation, A minus 4 equals to AM equals to AS, we will derive that AS is also equals to A minus 4. AS equals to A minus 4. So we can write here that AS equals to A minus 4. In the next step, we will focus on the common external point, point B. From the common external point, point B, we have two tangents to a small circle. The first tangent to the small circle is tangent BS, and the second tangent from point B is BL. So we have tangent BS and tangent BL. And according to rule number 2, the lengths of those two tangents must be equal to each other because they are exiting from the common external point B. Therefore, according to rule number 2, they must be equal to each other in their lengths. That is to say, BS equals to BL. Okay? BS equals to BL according to rule number 2. BS equals to BL according to rule number 2. So here BS equals to BL according to rule number 2. Here BL equals to BS according to rule number 2. But we have already found out that BL equals to B minus 4. So can I tell that BL equals to B minus 4? And from this equation, B minus 4 equals to BL equals to BS, we will derive that BS is also equals to B minus 4 units. BS is also equals to B minus 4 units. Here BS equals to B minus 4 units. So actually, AB, according to what's given us the question, AB is the diameter of the big circle, and the radius of the big circle equals to 13 units. So we define the radius of the big circle as capital R. So we know that the diameter is twice as long as the radius, so AB is twice as long as the radius, so AB equals to 2 times capital R. That is to say, it is equal to 2 times capital R equals to 13 units according to what is given us in the question. So in conclusion, we found out that AB equals to 26 units. From one side, the diameter AB equals to 26 units, but from the other side, we also know that AB equals to AS plus SB. AB equals to AS plus SB. AB equals to AS plus SB. So AB equals to AS, that is A minus 4. This is A minus 4 plus SB. SB is B minus 4. So in conclusion, we found out that AB equals to A minus 4 plus B minus 4. So AB equals to A plus B minus 4 plus minus 4 is minus 8. But AB equals to 26, so we can substitute AB by 26. So 26 equals to A plus B minus 8. We add 8 to this equation, and we'll get that A plus B, according to equation number 1, equals to 26 plus 8 is 34. Here we'll square equation number 1, and we'll get that A plus B squared equals to 34 squared, that is actually 1156. So we found out that A plus B squared equals to 1156. We'll open the brackets on this side of the equation. According to the formula, the algebraic identity that A plus B squared equals to A squared plus B squared plus 2 times AB. So A plus B squared equals to A squared plus B squared plus 2 times AB, and it is equal to 1156. Okay. So we know that triangle ABC is a right triangle because of the fact that angle ACB, this angle equals to 90 degrees. So we'll implement the Pythagoras theorem on the right triangle, triangle ACB. According to the Pythagoras theorem, we get that AC squared in the right triangle ABC by PT is by Pythagoras theorem the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AC square plus BC square equals to the sum of the squares of the perpendiculars. So the square of the hypotenuse is AB, so the square of the hypotenuse is AB squared. So in conclusion, we found out that AB squared equals to BC squared plus AC squared. AB equals to C, so AB squared is C squared. That is equal to here AC equals to A, so AC squared is A squared plus BC equals to B, so BC squared is B squared. So in conclusion, we found out that A squared plus B squared equals to C squared. Okay? But C is equal to AB, that is the diameter of the circle, and the diameter of the circle equals 2 times the radius, that is to say 13 times 2, that is 26 units. So C equals to 26. C equals to 26, so C squared will be equal to 26 squared, and it is equal to A squared plus B squared. So according to equation number 2, we found out that A squared plus B squared equals to 26 squared. That is to say, according to equation number 2, we found out that A squared plus B squared equals to 26 squared. 26 squared is 676. So according to equation number 2, we found out that A squared plus B squared equals to 676. While according to equation number 1, we found out that A squared plus B squared plus 2 times AB equals to 1156. So because of the fact that a squared plus b squared equals to 676, it means that we can substitute a squared plus b squared in equation number 1 by 676. So here we do it now, we get that here a squared plus b squared is 676 according to equation number 2. So we substitute a squared plus b squared by 676 plus 2ab equals to 1156. Okay, so we subtract 676 from this equation number 1, and we get that 2 times AB equals to 480. So according to equation number 1, 2 times AB equals to 480. We divide equation number 1 by 2, and we get that according to equation number 1, A times B equals to 480 over 2. 480 over 2 is 240. Okay. And what is the blue area actually? What is the blue area? The area of triangle ABC. The area of triangle ABC minus the area of the small circle will give us the blue area. Okay. I repeat again. The blue area equals to the area of triangle ABC minus the area of the small circle. Very simple. It is very clear from the drawing that if we subtract the area from the area of triangle ABC, the area of the small circle, we get the blue area. So the blue area equals to the area of triangle ABC. The area of triangle ABC, it is equal to, here we have the base of the triangle. Actually, here the base of the triangle is AC times the height to the base is CB over 2. I'll repeat again, the area of triangle ABC equals to the base that is AC times the height that is CB over 2. So AC, and minus the area of the small circle, the radius of the small, so the area of the small circle is pi r squared, and r equals to 4 units. So the blue area will be equal to, here, AC equals to A, BC equals to B, so it is A times B over 2, minus pi r square. Pi times r is 4, so r square is 4 square. 4 square is 16. So actually we found out that the blue area equals to the area of triangle ABC, that is AB over 2, minus 16 pi, that is the area of the circle. Here, according to equation number 1, AB equals to 240. We divide equation number 1 by 2, and we get that AB over 2 equals to 120. So here we can write down that AB over 2 equals to 120. So the blue area is equal actually to 120 minus 16 pi. So it is actually the blue area equals to 120. This is the blue area is equals to 120 minus 16 pi square units. Or in terms of numbers, is equal to 69.73. Check that I'm not mistaken. 16 times pi. So the area of the blue area equals to either 120 minus 16 pi square units, or in terms of numbers, it is equals to 69.73 square units. Okay, so we finished with the first question. In the next step I will present to you the next question, question number 2, and we will solve the question number 2 in 3 different methods. Okay. In the drawing, we have triangle that is inscribed by a circle, and side AB of triangle ABC equals to 5 units, side BC equals to 6 units, and we know that the area of triangle ABC equals to 9 square units, and we want to find out the area of this. We want to find out the radius of this circle that blocks the triangle ABC. Okay, so we start with the first method. In the first method, from point A, we will draw perpendicular on BC. So this angle equals to 90 degrees according to our construction, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. So we know that the area of triangle ABC equals to 9 square units. and the area of any triangle equals to the base of the triangle. In this case it is BC, that equals to 6 units, times the height to the base. The height to the base is AD, why? Because AD is perpendicular to the base BC. So it is BC is the base, times AD, that is the height, over 2. I repeat again, the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is AD, over 2. BC equals to 6 units, times AD, over 2. 6 over 2 is 3, so it is 3 times AD. In conclusion, we found out that 9 equals to 3 times AD. Here we divide this equation by 3, and we get that AD equals to 3 units. So we can write here that AD equals to 3 units. In the next step, we'll focus on triangle ABD. Triangle ABD is the right triangle according to our construction, because angle ADB equals to 90 degrees. In triangle ABD, we'll implement the Pythagoras theorem. In triangle ABD, according to the Pythagoras theorem, here by PT is the equation for Pythagoras theorem. In triangle, the right triangle, triangle ABD, we'll get that AB square, that is the square of the hypotenuse, minus AD square equals to BD square. This is according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So AB square minus AD square equals to BD square. AB equals to 5, so AB square is 25. Minus AD equals to 3, so AD square is 3 squared, that is 9. That is equal to BD square. So in conclusion, we found out that BD square equals to 25 minus 9. That is to say, BD square equals to 25 minus 9 is 16. We take out of this equation and we get that BD equals to the square root of 16, that is 4. We found out that BD equals to 4 units. So we can write here that BD equals to 4 units. What is the length of DC? From the drawing, it is very easy to see that DC equals to BC minus BD. BC minus BD equals to DC. So DC equals to BC. BC equals to 6 units according to what is given as the question, minus BD. We just right now found out that BD equals to 4 units. So in conclusion, we found out that DC equals to 6 minus 4, that is 2. So DC equals to 2 units. So we can write here that DC equals to 2 units. Here we will implement the Pythagoras theorem on triangle ADC in order to find out the hypotenuse. So in triangle ADC, this right triangle, according to the Pythagoras theorem, by PT is the equation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So AD square, so this equals to 2 units, of course. So DC square, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, equals to AD squared, that is 3 squared, is 9, plus DC squared, that is 2 squared, that is 4. So in conclusion, DC squared, that is the square of the hypotenuse, it is actually AC squared. Here, in triangle ADC, the square of the hypotenuse is AC squared, and AC squared equals to AD squared plus DC squared. AD squared is 3 squared, that is 9, plus DC squared is 4. So in conclusion, we found out that the square of the hypotenuse in triangle ADC equals to 9 plus 3 is 13. AC squared equals to 13. We take out of this equation, we get that AC equals to the square root of 13 units. So here, AC equals to the square root of 13 units. Here we will make a construction. First of all, from point A, we define the center of this circle as point O. And from point A, we join points A and O together by a straight line. And then we will extend line segment AO until it touches the circle. At this point, we define the touching point of the extended line segment AO with the circle as E. So here, AE is line segment that passes through the center. Any chord inside a circle that passes through the center of the circle, it is defined as the diameter. So here AE is the diameter of the circle. Why? Because it passes through the center of the circle. So AE is the diameter of the circle. We will connect points, we join points B and D together by a straight line. And we actually have a new rule that says that any peripheral angle that rests on the diameter of the circle is equal to 90 degrees. The diameter of this circle is AE, as I already mentioned. A is the diameter. We have peripheral angle ABE. This angle rests on AE, that is the diameter. So according to the rule that I mentioned just right now, the peripheral angle ABE that rests on the diameter of this circle must be equal to 90 degrees. That is to say, angle ABE equals to 90 degrees, according to the rule that I mentioned, that any peripheral angle that rests on the diameter must be equal to 90 degrees. So angle ABE equals to 90 degrees. And we actually have another rule that peripheral angles that rest on the same chord are equal to each other. Okay, I repeat again, peripheral angles that rest on the same chord are equal to each other. If we focus on chord AB, we have angle ACB rests on chord AB, and also angle AEB rests on the same chord, chord AB. So according to the rule that I mentioned, angle ACB must be equal to angle AEB. Angle ACB must be equal to angle AEB. I'll repeat again, angle ACB equals to angle AEB because of the fact that those two angles are defined as peripheral angles and the rest of the same chord, therefore they must be equal to each other in their sizes. Okay? So angle ACB, this angle must be equal to this angle that is actually angle AEB. So if we define angle ACB as theta, so if this angle equals to theta, according to our definition, then from this equation theta equals to angle ACB equals to angle AEB, we will derive that angle AEB is also equals to theta. Okay, so actually this angle equals to theta. Actually we have here triangle AB is the right triangle. Angle ABE equals to 90 degrees. Angle ABE, this angle equals to 90 degrees, it is the right angle. Angle AEB, this angle equals to theta. So this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this entire triangle AB to 180 degrees, this angle must be equal to 90 degrees minus theta. Likewise, for the same reason, if we focus on triangle ADC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. In the next step, we will prove that right green triangle AEB is similar to the right green triangle ADC. So why those two right green triangles are similar to each other? So write it down. We put that the right green triangle ABE is similar to the right green triangle ADC. So why those two green triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. Okay? So write it down that angle ABE equals to angle ADC, and they are both equal to 90 degrees. Okay, angle AB equals to angle ADC equals to 90 degrees. Those two angles, they are both equal to theta, therefore they are equal to each other. So angle AEB is equal to angle ACD and they are both equal to theta, therefore they are equal to each other. And those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Okay, so angle BAE is equal to angle DAC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. Okay? So actually prove that all three angles in triangle ABE can go to all three angles in triangle ADC. That is to say, triangle ABE is similar. This is the sign of similar to triangle ADC according to angle similarity rule. From the fact that the two grand triangles are similar to each other, we will conclude that the following equation is true, that AB over AD, AB over AD equals to AE over AC. I repeat again, from the fact that the two grand triangles are similar to each other, we conclude that AB over AD equals to AE over AC. Here, AB equals to 5 units, AD equals to 3 units, AE, as I already mentioned, is the diameter of the circle, that is to say, it is twice as long as the radius, and the radius of this circle is capital R, so the diameter will be equal to 2 times capital R, 2 times capital R, so A is 2 times the radius of the circle over AC. We have already found out that AC equals to a square root of 13 units. So in conclusion, we found out that 5 over 3 equals to 2R over square root of 13 units. Here we multiply this equation by square root of 13 units, square root of 13, and we get that 5 times square root of 13 over 3 equals to 2R. We divide this equation number 1 by 2, and we get that the radius of the circle equals to 5 over 6 times square root of 13 units. In terms of numbers, it is equal to about 3 units, a little bit more than 3 units. 3.00. Okay, so the radius of this circle, so here, check it. So it is about a little bit greater than 3 units. Okay, so the radius of this circle equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is equal to 3.00, a little bit greater than 3 units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the radius of this circle that blocks triangle ABC according to the second method. In the second method, we'll use the things that we already found out in the first method. So here from point A, we draw perpendicular on BC. This is point D. We have already found out that DC equals to 2 units, AD equals to 3 units according to the first method, and BD equals to 4 units. So I will not repeat on it. In the next step, we will extend line segment AD by a straight line until it touches the circle, and we define the touching point of the extended AD, and the circle is E. And here we have, so here those two angles are equal to 90 degrees according to our construction. But according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, actually AD is one side of, make a perpendicular from point A on BC. So AD is absolutely, it's a perpendicular, it must be a straight line. Then we extended the straight line AD by a straight line, and we extend a straight line by a straight line, the result must be also a straight line, so AE must be a straight line. So if we focus on this side of the straight line AE at point D, then the sum of the angles here must be equal to 180 degrees. So this angle equals to 90 degrees, plus this angle, in total they must be equal to 180 degrees. So this angle must be also equal to 90 degrees. In order to complete the sum of the angles to 180 degrees, this angle must be also equal to 90 degrees. Likewise, if we focus on this side of the straight line AE at point D, then the sum of the angles here must be equal to 180 degrees. So this angle equals to 90 degrees, and this is the missing angle. The sum, in total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. So 90 degrees plus angle BDE must be equal to 180 degrees. If we subtract 90 degrees from the equation, we get that angle, the missing angle, angle BDE equals to also 90 degrees. So we actually found out that all the angles around point D are right angles. Okay. And we have rule that I mentioned in the past. So I'll repeat on it very quickly. So this will be rule number 1. According to rule number 1, if chord AB, this is chord AB, intersects with chord CD, this is chord CD, at point O is the intersection point, then the following equation is true. So all must be inside the circle, of course. The following equation is true, that AO times OB equals to CO times OD. I'll repeat again. If chord AB intersects with chord CD at point O is the intersection point, then inside the circle, of course, then AO times OB equals to CO times OD. We actually can implement rule number 1 in our circle. Why? Because in our circle we have chord AE, it intersects with chord BC at point D. Point D is the intersection point, therefore according to rule number 1, we get that BD times DC equals to AD times DE. Okay, BD times DE equals to AD times DE. BD equals to 4 units. DC equals to 2 units. We already found out those 9 segments in the first method. And it is equal to AD. AD also equals to 3 units according to the first method. Times DE. DE is the missing 9 segments. So 4 times 2 is 8. 8 equals to 3 times DE. We divide this equation by 3. And we get the DE equals to 8 over 3 units. Here D equals to 8 over 3 units. Okay. In the next step, I present to you rule number 2. According to rule number 2, if chord AB intersects with chord CD at 90 degrees, they intersect with each other at 90 degrees, then the following equation is true. So here we have chord AB. This is chord AB. Intersects with chord CD, and they intersect with each other at 90 degrees. So here we have 90 degrees between them and the intersection point. Okay. We will define the intersection point as point O. CO equals to A, OD equals to B, AO equals to C, and OB equals to D. Then according to rule number 2, the following equation is true. That 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Okay? R is the radius of the circle. Okay, is the radius of the circle that contains the 2 chords. Radius of the circle we can implement rule number 2 in our drawing because we already found out that chord AE intersects with chord BC at point D at 90 degrees. We already found out that all the angles at point D around point E, they are equal to 90 degrees, therefore they intersect, chord AE intersects with chord BC at 90 degrees. Therefore we can implement rule number 2 in our drawing. So, and we get that according to rule number 2, 4 times R squared, that is the radius of this circle, that is equal to capital R, equals to BD squared. plus DC square plus AD square plus DE square. Repeat again. Because of the fact that chord AE intersects with chord BC at 90 degrees, then we can implement here rule number 2. And according to rule number 2, we get that 4 times R square equals to BD square plus DC square plus AD square plus DE square. Okay, 4R square equals to BD square plus DC square plus AD square plus DE square. So 4 times R square, 4 times R square equals to BD square. BD equals to 4, so BD square is 4 squared, that is 16, plus DC square. DC equals to 2, so this square is 2 squared, that is 4, plus AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. DE equals to 8 over 3, therefore DE square will be equal to 8 square over 3 square, that is 64 over 9. So in conclusion, found out that 4 times R square equals to 16 plus 4 plus 9 plus 64 over 9. 16 plus 4 is 20, 20 plus 9 is 29, so here we have 29 plus 64 over 9. Here we'll multiply 29 by 9 and then we'll divide it by 9 in order to have a common factor with this expression, and we get that it will be equal to 2 times 261 plus 64 over 9. So 4 times R square equals to 261 plus 64 is 325 over 9. Here we'll divide this equation by 4 and we get that R square equals to 325 over 4 times 9 is 36. 325, it is equal to 25 times 13 over 36. Here we take a root out of this equation and we get that R equals to the square root of 35 is 5 over square root of 36 is 6 times square root of 13. So in conclusion, we found out that R, the radius of this circle that blocks triangle ABC, it is equal to 5 over 6 times square root of 13 units, so in terms of numbers it is equal to 3.00, a little bit than 3 units. Okay, so we finished with the second method. The next step I present to you how to find out the radius of this circle that blocks triangle ABC according to the third method. Actually here triangle ABC is described by this circle. Here we define angle ABC as theta. We know that the area of any triangle if we have triangle ABC, this is triangle ABC. This is angle theta. The length of side AB equals to A units, the length of side AC equals to B units. Then the area of this triangle ABC, is equal to A times B times sinus theta over 2. Okay? So we calculate the area of this triangle according to the same formula. So it will be equal to A times B times sinus theta over 2. A equals to 5 units, B equals to 6 units, times sinus theta over 2. But we know that the area of triangle ABC equals to 9 units. It is given as the question. 5 times 6 is 30. So 9 equals to 30 over 2 is 15 times sinus theta. Here we divide this equation by 3 and we get that nine over 3 is 3, 15 over 3 is 5 times sinus theta. Here we divide this equation by 5 and we will find out that sinus theta equals to 3 over 5 units. Sinus theta equals to 3 over 5 or 3/5. We actually have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. If here cosine theta equals to the square root of 1 minus sinus square theta. If sinus theta equals to 3 over 5, it means that sinus square theta will be equal to 3 over 5 squared, that is 9 over 25. So it is minus 9 over 25. This is sinus square theta. We can substitute 1 by 25 over 5. 1 equals to 25 over 25. So in conclusion, we found out that cosine theta equals to 25. 25 minus 9 is 16 over 25. Okay. The square root of 16 is 4. The square root of 25 is 5. So, in conclusion, we found out that cosine theta equals to 4/5. Cosine theta equals to 4/5. In the next step, we'll implement the law of cosines in our triangle ABC. Okay, I'll repeat again on the law of cosines. According to the law of cosines, the law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. This is again theta. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. And the angle between side AB and side AC is theta. Then according to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we implement the law of cosines in our triangle ABC. Okay, so here cosine theta will be equal to AB squared, that is 5 squared 25, plus BC squared, BC is 6, so BC squared is 36, minus AC squared, that is the missing line segment, the missing side, over 2 times 5 times 6. So here we'll get that actually we have already found out that cosine theta equals to 4 over 5. Here cosine theta equals to 4 over 5, so we can substitute cosine theta by 4 over 5. And it is equal to 25 plus 36 is 61 minus AC squared over 5 times 6 is 30 and 30 times 2 is 60. Here we will divide this equation, we'll multiply this equation by 5 and we get that 4 equals to 61 minus AC squared and 60 over 5 is 12. Here we'll multiply this equation by 12. 12 times 4 is 48 equals to 61 minus AC squared. So here AC squared equals to 61 minus 48 is 13. So AC equals to the square root of 13 units. So we found out that AC equals to the square root of 13 units. Actually, we have a formula that deals on the occasions that circle blocks triangle. Here we have triangle ABC is described by this circle. Therefore, according to the following formula, the area, the radius of this circle that blocks triangle ABC will be equal to the multiplication of all the sides of triangle ABC. So it is AB times AC times BC, AB times AC times BC over 4 times the area of triangle ABC. I repeat again, the radius of any circle that blocks triangle is defined by the multiplication of the sides of the triangle that is blocked by the circle over 4 times the area of the triangle that is blocked by the circle. So capital R will be equal to AB is 5, AC is square root of 13 units, BC is 6 over 4 times the area of triangle ABC. It is given us the question that the area of triangle ABC equals to 9 square units. So in conclusion, we found out that R equals to 5 times 6 times square root of 13, 4 times 9 is 36. So here we divide this equation by 6 and we get that R equals to 6 will get cancelled and then we left only with 6. So in conclusion, we found out that the radius of the circle that blocks triangle ABC equals to 5 over 6 that times square root of 13 units, that is a little bit greater than 3 units. 3 times 0, 0 units. Okay? So we finished with the third method. In the next step, I'll summarize the lecture. We'll start with the first question. the first question, we have here a circle. Inside this, the big circle, we have triangle ABC, and inside triangle ABC, we have a circle that is inscribed by triangle ABC, and we want to find out the area of the blue area. Okay. So first of all, we define the center of the small circle as point O. Then we join points O and L together by a straight line. L is the point of tendency of tangent BC with this small circle. So OL is the radius of this circle, that is equal to 4 units. So the radius OL, it is drawn to the point of tendency. And whenever you have a radius that is drawn to the point of tendency, then according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here the radius OL, it is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent CB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius OL. So if CB is perpendicular to OL, it means that this angle equals 90 degrees and this angle will be also equal to 90 degrees. Likewise, we join points O and M together by a straight line. O is the center of the circle, M is the point of the small circle itself. This is exactly the definition for radius. So here we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AC with the circle. Whenever you have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius MO. So AC is perpendicular to MO according to rule number 1. That is to say, this angle equals 90 degrees and this angle will be also equal to 90 degrees. Okay? It is given us the question that AB is the diameter of the big circle. And we have the rule that states that any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. So if peripheral angle ACB, this angle ACB rests on the diameter of the circle, therefore peripheral angle ACB must be equal to 90 degrees. So angle ACB equals to 90 degrees. Therefore, quadrilateral OLMC, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle LOM. In total, they must be equal to 360 degrees. So here, we subtracted 270 degrees from this equation and found out that the missing angle LOM equals to 90 degrees. So this angle LOM equals to 90 degrees. Therefore, actually in quadrilateral MOLC, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral MCLO as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other, so the opposite sides of rectangle LOMC are equal to each other. They are equal to each other. So according to this rule, we'll get that OL equals to MC. OL equals to MC. But if OL equals to 4 units, this is the radius of the circle. So here OL equals to 4, from this equation 4 equals to OL equals to MC, we derive that MC is also equals to 4 units. If MC is also equals to 4 units, likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MO equals to CL. Here MO equals to CL. But we found out that MO equals to 4 units. It is the radius of the small circle. So MO equals to 4, and from this equation 4 equals to MO equals to CL, we will derive that CL is also equals to 4 units. Here, CL equals to 4 units. Okay? So actually, we found out that the quadrangle M of CL is a square, and then I presented to you rule number 2. Actually, we defined side AC of triangle ABC as A, side BC as B, and side AB as C. Okay, yeah. AC equals to A, CB equals to B, and AB equals to C. And what is the length of side AM? If AM equals to AC minus MC. AM equals to AC minus MC, so AM equals to AC, that is A according to our definition, minus MC, that is 4. So in conclusion, we found out that AM equals to A minus 4. Likewise, what is the length of side segment LB? LB from the drawing is very easy to see that LB equals to CB minus CL. LB equals to CB minus CL. That is to say LB equals to CB, that is B according to our definition, minus CL, that is L, that is 4. CL is 4. So in conclusion, we found out that LB equals to B minus 4. Here LB equals to B minus 4. And then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Okay, so whenever you draw two tangents to a circle from a common external point to the circle, then the lengths of those two tangents must be equal to each other. So if we focus on the common external point, point A, we have two tangents to this small circle, tangent AM and tangent AS, and according to rule number 2, they must be equal to each other. If AM equals to AS according to rule number 2, okay, but AM equals to A minus 4. You know that AM equals to A minus 4, so from this equation A minus 4 equals to AM equals to AS, we derive that AS is also equals to A minus 4. Here AS is also equals to A minus 4. Then we focus on the common external point, point B. From the common external point, point B, we have two tangents to the small circle, tangent BS and tangent BL. And according to rule number 2, they must be equal to each other in their lengths. Okay, so here at point B, BS must be equal to BL according to rule number 2. But here BL equals to B minus 4 according to what we already found out. So here BL equals to B minus 4. And from this equation B minus 4 equals to BL equals to BS, we will derive that BS is also equals to B minus 4. Here BS is also equals to B minus 4. It is given us the question that AB is the diameter, and the diameter is always twice as long as the radius. So if the radius of this circle is equal to capital R, then the diameter AB must be equal to 2 times capital R. So AB equals to 2 times capital R, and it is given us the question that the radius of the big circle equals to 13 units. Therefore, the diameter AB is twice as long as the radius, that is to say it is equal to 2 times 13, that is 26 units. Okay? Then we have, according to what we already found out, here AB equals to AS plus SB. From the drawing it is very easy to see that AB equals to AS plus SB. Here AS equals to A minus 4 and SB equals to B minus 4. So AB equals to A plus B minus 4 is minus 8. So AB equals to A plus B minus 8. And here we know that the diameter is twice as long as the radius, and the radius is 13. Therefore, the diameter will be equal to 26. So the diameter of 26 equals to A plus B minus 8. We added 8 to this equation and found out that AB equals to 26 plus 8 is 34. So AB equals to 34 units. Then we squared both sides of equation number 1. We found out that AB squared equals to 34 squared, that is 1256. We opened the brackets on this side of equation number 1. We found out that A plus B squared equals to A squared plus B squared plus 2 times AB. It is equal to 1156. Okay. Then, because of the fact that angle ACB is a right angle, therefore triangle ACB is a right triangle, so we can implement the Pythagoras theorem on the right big triangle, triangle ACB. The triangle ACB, according to the Pythagoras theorem, AC squared plus BC squared equals to the hypotenuse squared, that is AB squared. AC equals to A, so AC squared is A squared, BC equals to B, so BC squared is B squared, and AB equals to C, so AB squared is C squared. And A squared plus B squared equals to, here, C equals to 26 because the diameter of the circle equals to 26 units. So we substitute the diameter by 36. So it is A squared plus B squared equals to the diameter squared, that is 26 squared. So A squared plus B squared equals to 26 squared, that is 676. And according to equation number 1, A squared plus B squared plus 2 times AB equals to 1156. So here we substitute A squared plus B squared in equation number 1 by 676 from equation number 2, because of the fact that A squared plus B squared equals to 676 according to equation number 2. And we got that 676 plus 2 times AB equals to 1156. Here we subtracted 676 from this equation, equation number 1. And found out that 2 times AB equals to 1156 minus 676 is 480. So here we have 2 times AB equals to 480. We divided this equation number 1 by 2, and we got that 2 times AB is 2AB over 2 is AB, and 480 over 2 is 240. So we found out that A times B equals to 240. Then what is the value of the blue area? The blue area is equal actually to the area of triangle ABC, the big triangle ABC, minus the area of the small circle. It is very easy to see. It's that the area of the big triangle ABC minus the area of the small circle equals to the blue area. I repeat again, the blue area equals to the area of the big triangle ABC minus the area of the small circle. So the blue area equals to the area of triangle ABC. The area of triangle ABC equals to, here it is the base of the triangle is AC times the height to the base is CB over 2. Again, AC is the base times CB is the height to the base over 2. Why CB is the base? Because CB creates 90 degrees with the base AC. Therefore, CB is the height to the base. Okay, so it is AC times CB over 2 minus the area of the small circle. The area of the small circle is pi r squared, and r equals to 4 units. And here, AC equals to A, according to our definition. CB equals to B. So here, AC times CB over 2 is AB over 2. So if I found out that AB equals to 240, if AB equals to 240, it means that AB over 2 will be equal to 120. We divided this equation by 2, and we got that AB over 2 equals to 120. So here AB over 2 equals to 120 minus pi r squared. R is equals to 4, so r squared is 4 squared. that is 16. So the blue area equals to 120 minus 16 pi. So the blue area equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 units. Here, this blue area equals to either 120 minus 60 pi square units, or in terms of numbers, it is equal to 69.73 square units. We finished with the first question. Then I presented to you 3 different methods to solve the second question. So in the second question, we have in the drawing triangle ABC. Triangle ABC is blocked by the circle, so triangle ABC is inscribed by the circle. And we know that here the area of triangle ABC equals to 9 units, side AB of triangle ABC equals to 5 units, side BC equals to 6 units, and we want to find out the radius of this circle that blocks triangle ABC. So first of all, from point A we draw perpendicular on BC, so this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. Okay? So we know that the area of triangle ABC equals to 9 units, and the area of triangle ABC equals to the base of the triangle that is BC times the height AD over 2. The area of triangle ABC that is equal to 9 units according to what is given as the question equals to the base BC times the height AD over 2. The base BC equals to 6 units according to what is given as the question, times the height AD over 2 is equal to 9. So 6 over 2 is 3, so we get that 9 equals to 3 times AD. Here 9 equals to 3 times AD. We divide this equation by 3 and we get that AD equals to 3 units. Here we found out that the height AD equals to 3 units. And then we implemented the Pythagoras theorem on triangle ABD, the right triangle, triangle ABD. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AB square minus AD square equals to DB square. AB square minus AD square equals to BD square. AB equals to 5, so AB square is 5 squared, that is 25. Minus AD is 3, so AD square is 3 squared, that is 9. So BD square equals to 25 minus 9, that is 16. So BD square equals to 16. We took out of this equation and found out that BD equals to 4 units. BD equals to 4 units. From the drawing it is very easy to see that DC equals to BC minus BD. Again, DC equals to BC minus DC. BC equals to 6, DB equals to 4. So DC equals to 6 minus 4, that is 2. So DC equals to 2 units. Then we implemented the Pythagoras theorem in order to find out the hypotenuse. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So 3 square plus 2 square. Here will be AC square equals to 3 square, that is 9, plus 2 square, that is 4. So AC square, the square of the hypotenuse, equals to 13. Therefore, the hypotenuse itself equals to the square of 13 units. Here AC equals to the square root of 13 units. Then we have here from point A, we join points A and O together by straight line. O is the center of the circle, and we extended AO by straight line until it touches the circle at point E. Then we join points E and B together by straight line. And here we have actually angle A. We know that AOE is the diameter of this circle because it passes through the center. Any chord that passes through the center of the circle must be the diameter. So AOE is the diameter of the circle, and the peripheral angle ABE rests on the diameter. Any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. So angle ABE equals to 90 degrees. Okay, and here those two angles, they both rest on chord AB, therefore they must be equal to each other. So here angle ACB equals to angle AEB. So if one angle equals to theta, then the other angle must be also equal to theta. Then we proved that those two triangles, great triangles, are similar to each other. First of all, in triangle ABE, this angle equals to 90 degrees. This angle equals to theta, so this angle must be equal to 90 degrees minus theta. The same thing is true in triangle ADC, because of the fact that this angle equals to 90 degrees. This angle equals to theta, this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the triangle to 180 degrees. Then we proved that those two right-angled triangles are similar to each other. Why? Those two angles, they are both right angles, therefore they are equal to each other. Those two angles, they are both equal to theta, therefore they are equal to each other. And those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So all the angles of the triangle AB can go into angles of the angles of triangle ADC, therefore those two right triangles are similar to each other according to angle similarity rule. And for the fact that those two green triangles are similar to each other, we will derive that here AB over AD equals to AE over AC again. AB over AD equals to AE over AC. Okay? AB is 5, AD is 3. AE is the diameter that is 2R, and AC is square root of 15, square root of 13. So we multiply this equation by square root of 13, and we found out that 2R equals to 5 times square root of 13 over 3. We divided this equation number 1 by 2, and finally we found out that the radius of this circle that blocks triangle ABC is equal to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, so we finished with the first method. Next step I will present to you how we found out the radius of this circle that blocks triangle ABC according to the second method. Okay. In the second method, we use the same thing that we have already found out in the first method. We have already found out that AD equals to 3 units. Actually, from point A we draw perpendicular on BC, so AD is here, it is 90 degrees, and here it is 90 degrees. AD equals to 3 units according to what we have already found out in the first method. BD equals to 4 units, and DC equals to 2 units, according to what we have already found out in the first method. Then we extended line segment AD by straight line until it touches the circle at point E. Then I presented to you rule number 2, according to rule number 2, if called a rule number 1, according to rule number 1, if chord AB intersects with chord CD at point O is the intersection point, then AO times BO equals to CO times DO. Again, AO times BO equals to CO times DO. Okay, so we can actually implement rule number 1 in our drawing. Why? Because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. BD is 4, DC is 2, AD is 3, and DE is the missing line segment. So here 4 times 2 equals to 3 times DE. 4 times 2 is 8. 8 equals to 3 times DE. We divided this equation by 3 and we found out that DE, the missing line segment DE equals to 8 over 3 units. Then we implemented rule number 2 in our drawing. First of all, according to our construction, this angle equals to 90 degrees and this angle also equals to 90 degrees. So the rest, the other two angles must be also equal to 90 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so all the angles around point D are right angles. Then I presented to you rule number 2. According to rule number 2, if chord AB intersects with chord CD, it's 90 degrees. Then the following equation is true, that 4 times r squared, r is the radius of the circle that contains the two chords. 4 times r squared equals to a squared plus b squared plus c squared plus d squared. Okay? So, we implemented rule number 2 in our drawing. According to rule number 2, we get that 4 times r squared, that is the radius of this circle that we are looking for, will be equal to bd squared plus dc squared plus ad squared plus de squared. Here again, 4 times a squared equals to bd squared plus dc squared plus ad squared plus de squared. So 4 times r squared equals to bd is 4, so bd squared is 16. dc is 2, so dc squared is 4. ad is 3, so ad squared is 9. D is 8 over 3, so D squared is 8 over 3 squared, that is 64 over 9. 16 plus 4 is 20, 20 plus 9 is 29, so here we will have 29 plus 64 over 9. Here we multiply 29 by 9 and then we divide it by 9 in order to overcome a factor with this expression. 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 325 over 9 equals to 4r squared. Here we divided this equation by 4 and found out that r squared equals to 325 over 64. But 325 is 25 times 13. We substituted 325 on 25 times 13 over 36. We took out of this equation, we found out that r equals to the square root of 25 is 5, the square root of 36 is 6. So in conclusion, we found out that the radius of the circle equals to 5 over 6 times square root of 13, or in terms of numbers, it is a little bit greater than 3 units. Then I presented to you a second method to find out the radius of this circle that blocks triangle ABC. According to the third method, we defined angle ABD as theta. Then we actually have a new special formula to find out the area of any triangle. If this is a triangle ABC, that could be any triangle. The angle between side AB and side AC is theta. Side AB equals to A units in its length, side AC equals to B units in its length. Then the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. So according to this formula, we found out the area of this triangle, triangle ABC. The area of this triangle, triangle ABC, with this angle theta, will be equal to 5 times 6 times sinus theta over 2. According to this formula, it will be equal to 5 times 6 times sinus theta over 2. 5 times 6 is 30. 30 over 2 is 15. So we found out that 9 equals to 15 times sinus theta. We divided this equation by 3 and we found out that 3 equals to 9 over 3 is 3 and 15 over 3 is 5. So in conclusion we found out that 3 equals to 5 sinus theta. We divided this equation by 5 and we found out that sinus theta equals to 3/5. Then we have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. If sinus theta equals to 3/5, it means that sinus square theta will be equal to 3/5 square, that is 9 over 25. So here cosine theta will be equal to 1, but 1 is 25 over 5, minus sinus square theta is 9 over 25. So in conclusion, cosine theta equals to the square root of 25 minus 9 over 25. 25 minus 9 is 16 over 25. And the square root of 16 is 4, the square root of 25 is 4. So in conclusion, found out that cosine theta equals to 4/5. Cosine theta equals to 4/5. Here, we found out that cosine theta equals to 4/5. Then we implemented the law of cosines in our triangle, triangle ABC. According to the law of cosine, this is triangle ABC that could be any triangle. Side AB equals to A units, side AC equals to B units, and side BC equals to C units. Then according to the law of cosines, we get that cosine theta equals to A square plus B square minus C square over 2 times A times B. So in our specific triangle, triangle ABC, we get that cosine theta equals to 5 square plus 6 square over 2 times 5 times 6. Okay? And cosine theta equals to 4/5. So 4/5 equals to 25 plus 36 is 61, minus AC square is the missing line segment, over 5 times 6 is 30, and 30 times 2 is 60. So 4 equals to 61 minus AC square. Here we actually multiplied this equation by 5. So 4/5 times 5 is 4, and here we have 60 over 5 is 12. So in conclusion, we found out that 4 equals to 61 minus AC square over 12. We multiply this equation by 12 and we got that 12 times 4 equals to 48, and 48 equals to 61 minus AC square. 61 minus 48 is 13, so we found out that AC square equals to 13. That is to say, AC equals to the square root of 13 units. So we found out that AC equals to the square root of 13 units. And we have a special formula in order to find out the radius of a circle that blocks a triangle. According to this formula, the radius of the circle that blocks triangle will be equal to the multiplication of the three sides of the triangle that blocked by the circle. In this case, it will be equal to AB times AC times BC over 4 times the area of triangle ABC. So here AB equals to 5, AC equals to square root of 13 units, and here BC equals to 6. So it is 5 times square root of 13 times 6 over 4 times the area of triangle ABC, and the area of triangle ABC is 9. So it is 4 times 9. 4 times 9 is 36. here. So here we have 5 times 6 times square root of 15 over 6. We divided this equation by 6, so here 6 will get cancelled, and 36 over 6 is 6. So in conclusion, I found out that the radius of the circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is equal to 3.00, a little bit than 3 units. Okay? So in all 3 methods we found out, we arrived to the same radius. The radius of the circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit bigger than 3 units. Okay, thank you very much.